Hello everyone, my name is Sudheer Kumar, working as an Assistant Professor of Mathematics, MLR Institute of Technology. In this lecture, I am going to discuss about double integrals. So this is the overview, double integrals. Let us see geometrical interpretation and problems on it. So double integrals generally represented with double integral of some function of x and y dx dy, right? F is a function of two variables x and y, so we denote this double integral with this. We can represent this geometrical meaning in different cases. Case 1, when both x and y limits are constants. Right? So, for example, x is equal to a to b, y is equal to c to d, some function of x and y dx dy. To evaluate this double integral, see the limits. X limits are varying from a to b, y limits are varying from c to d. Evaluate this double integral. Both x and y limits are constants, so let us represent this double integral geometrically. So this is x axis and this is y axis, this is origin. X varies from a to b, so this is the line x equal to a, this line represents x equal to a, and this line represents x equal to b. Similarly, y varies from c to d, so y is equal to c is this line, y equal to d is this line. So this is the line y equal to d, this is the line y equal to c. So between these two lines and these two lines we have to find. So where is the common area? The region of integration is this one. This is the area. Double integration means we are finding the area of which region, means this region we have to find this area, right? Suppose case 2, let us take x varies from a to b and y varies from some function of x to some function of another function of x. So here y is a variable limit and x is a constant limits. In this case, how to represent this double integral geometrically? Let us see. So x is equal to a to b, and so this is the line x equal to a, this is x axis, this is the line x equal to b, and y is some function of x, this is f1 of x and this is f2 of x. Between these two lines and these two curves, this is the area which we have to find. Third case, to evaluate this double integral of f of x comma y dx dy, let us take c less than or equal to y less than or equal to d. So y is having constant limits c and d, and x varies from function of y, say g1 of y to g2 of y. Now x is a variable limit and y is having constant limits. To evaluate this double integral, how to denote this. So y is equal to c is this line, y equal to c. This is the line y equal to d, and this is the curve which is given by g1 of y, and this curve g2 of y. So between these two curves and between these two lines, we have to find the area. This is given by this. So in these three different cases, we evaluate the double integral. This is the all about geometrical interpretation. Let us see problems on it. Say for example, evaluate integral y equal to 0 to 2, x equal to 0 to 3, xy dx dy. We can observe that both x limits and y limits are constant, so there is no order in which you can integrate. First you integrate with respect to x and with respect to y, or first you integrate with respect to y, then with respect to x. Right. Let us take y is equal to 0 to 2, integral x equal to 0 to 3, xy dx, then dy. First let us integrate with respect to x. So what is integration of xy dx? That is x square by 2 into y dy, and x limits are 0 to 3, right? So y is equal to 0 to 2. Substitute the lower limit and upper limit in place of x. X square means 3 square, that is 9 by 2, minus lower limit is 0 into y dy. So 9 by 2 into, what is integration of y dy? Y square by 2, and y limits are 0 to 2. So this is 9 by 2 into, in place of y substitute the upper limit 2, 2 square is 4 by 2, 2. So 2 and 2 get cancelled, 9. So this is the answer, right? Let us take one more example now. Evaluate integral 0 to 1, integral x to root x, x square plus y square dx dy. To evaluate this integral, we can observe that what are x limits and what are y limits, but we have to identify. Here given that y is in terms of x, so y varies from x to root x and x varies from 0 to 1. So x limit is constant and y is in terms of x. So first integrate with respect to y first, and then with respect to constant limits, that is with respect to x. So first we have to integrate with respect to y. So x is equal to 0 to 1, y is equal to x to root x, x square plus y square dy, then dx. So x is equal to 0 to 1. What is integration of x square plus y square dy? That is x square y plus integration of y square dy is y cube by 3, and the limits are x to root x, then dx. So x is equal to 0 to 1. In place of y, substitute the upper limit x. So x square into root x plus y cube by 3 means root x whole cube by 3. This is upper limit, right? Minus lower limit, x square into x plus x cube by 3 whole dx. So this is integral x equal to 0 to 1. Root x means x power 1 by 2. X square into x power 1 by 2, that is x power 5 by 2. plus this is x power 3 by 2 by 3 minus x cube minus x cube by 3 whole dx. So 3x cube minus 4x cube by 3. So if you cancel this, this is 4x cube by 3. Now integrate this. So x power 5 by 2 integration is 5 by 2 plus 1, that is 7 by 2 by 7 by 2, that is 2 by 7, plus x power 3 by 2 integration is x power 5 by 2 by 5 by 2, that is into 2 by 5 by 3, minus 4 by 3 into x power 4 by 4, and the limits are, what are the limits? 0 to 1. So if you simplify this, we get 2 by 7 plus 1 by 15, here 4 and 4 get cancelled, minus 1 by 3. If you simplify this, we get, take out the LCM, and this is the 9 by 105. So 3 3s, 3 5s, that is 3 by 35. So this is how we evaluate the double integral. Let us see one more problem. Evaluate integral of 0 to 5, integral of 0 to x square, x into x square plus y square dx dy. So first write down what are x limits and what are y limits. Here given that y is in terms of x, so y varies from 0 to x square and x varies from 0 to 5. Since y is in terms of x, we integrate first with respect to y, then with respect to x. So x equal to 0 to 5, y is equal to 0 to x square, multiply this x into x square, that is x cube, plus x into y square, that is xy square, dy then dx, right? X equal to 0 to 5. What is integration of x cube dy? X cube into y, plus integration of xy square dy, that is x into y cube by 3, and the y limits are 0 to x square then dx. So x equal to 0 to 5, x cube into, in place of y substitute the upper limit x square, plus x by 3 into, in place of y write down x square, so y cube means x square whole cube, that is x power 6, minus lower limit, anyhow lower limit is 0, so we have to evaluate this integral. So this is integral 0 to 5, x cube into x square is x power 5 plus 1 by 3 into x power 6 is x power 7 dx. So this is equal to, what is integration of x power 5 dx? X power 5 plus 1 by 5 plus 1 plus x power 8 by 8, but already one more 3 is there here, so we get 24, and the limits are 0 to 5. So in place of x substitute the upper limit 5 power 6 by 6 plus 5 power 8 by 24. So if you take 5 power 6 common, this is 1 by 6 plus 5 square by 24. Further, if you want to simplify, 5 power 6 into LCM is 24. So 4 plus 1 into 5 square, sorry, this is 25. So 5 power 6 into 25 plus 4 is 29 by 24. This is how we evaluate the double integral. So next lecture we are going to see how to evaluate this double integral over the given region. Means the limits are not given. Based on the region, we have to identify the limits for x and y, then evaluate the double integral. Right? Thank you.